Everyone. Today I'm Billy. I'm Charlie. Oh my God, I'm Charlie Fay, and this is Billy Rennekamp, and we're here from the Interchain Foundation, and we're going to be talking to you a little bit about IBC, and this is the InterBlockchain Communication Protocol from the Cosmos SDK and the Cosmos ecosystem. It's going to be going live on Terra as part of the Columbus 5 upgrade. So we thought it would be good for you to understand a little bit more about what IBC is as a protocol and what it might enable you to do. So first, a little bit about us. Again, my name is Charlie. I have a background in intellectual property law. That's what I studied originally. But for the last few years, I've been working primarily as an engineer in the Ethereum ecosystem. Recently, I joined the Cosmos Interchain Foundation. I joined in March of this year. And my role in Cosmos has been to be the product lead of IBC, and I also have a role on the grants team.
I'm Billy Rennekamp. This is what we actually look like. Actually was trained in film and video is what I studied, but I started engineering in the crypto space, primarily on Ethereum back in 2017 as well. My roles in Cosmos are the Cosmos Hub product lead. I also work on the grants team, and I'm on the board of management at the foundation itself.
Cool. So one of the most valuable system design principles in the blockchain ecosystem has been composability. And we really saw this first embodied in Ethereum in the smart contract design system. This has really exploded in the last few years, not only in Ethereum, but also in other ecosystems, in Terra, etc., in the form of DeFi and the power of financial Legos. Obviously, what this has enabled has been huge for all blockchain ecosystems. And now we're seeing gradually a state where a lot of blockchains want to build a bridge to Ethereum to access some of this composability, but also a lot of blockchains want to build a bridge to each other. The primary approach is to build a bespoke bridge, and that's what we've seen previously. The bespoke bridges to ETH allows extension of ETH composability to other chains. It allows DeFi liquidity to flow as frictionless as possible between ecosystems. However, building bespoke bridges does have a few challenges. Running a bridge can be as complicated as running another chain project. A lot of bridges have their own validator sets and governance structures. Having bespoke bridges from every single chain to every single other chain also seems to be hugely redundant and increases the complexity of multi-hop interoperability. So, I mean, we see bridges like Wormhole coming from Solana and Terra, which is exciting, but also at the same time, if we imagine wormholes between every single chain, it just hugely increases complexity there. So what we want to present to you today is a little bit what we think the extension of composability could look like and what happens when DeFi logos hop between the space between chains and when not everything is actually happening on the same state machine. So what we think that looks like is embodied really in IBC. And what is IBC? I think one of the easiest ways to understand this is a shipping container metaphor, and this was first brought up by one of the core contributors to the Cosmos ecosystem, Sunny Arbol. And what it is basically the idea that right now, if you go to a port in every major city, you'll see a lot of shipping containers all stacked up together. The containers can contain anything. They can contain bikes, they can contain NFTs, they can contain fungible tokens. But what you'll notice is that every single shipping container, no matter what color and what company they're produced by, are all exactly the same sizes and they have the same dimensions. And this is really important because even though the shipping containers contain different things and they're all going to different ports, the people, the logistics providers, the ships, the transporters, they need to understand how to handle the containers so that the items that are inside these containers can arrive to their port of destination in the way that everyone expects them to arrive. And so what IBC is really the protocol that defines the dimensions for these shipping containers. It's a protocol that allows for arbitrary data transmission between arbitrary state machines. What we see is that IBC enables a global interchain. So IBC is a set of abstractions, but the set of abstractions alone doesn't actually determine what kind of security assumptions you have. Each chain can have their own security assumptions. IBC can handle async and synchronous communications, it can do timeouts, Basically, what we've designed IBC to do is handle the hardest security model. And that is what we're calling a dynamic topology. So that means validator sets that are unpredictable, that are dynamic, that don't have any kind of assumptions on what kind of sets they are. And IBC does this by relying on a system of handshakes, which are used to establish the connections, the channels, and then the ports, which are used by each chain to communicate with each other. And so previously, I mentioned a few assumptions. What I mean specifically is some chains like Polkadot and ETH 2.0, they have different types of assumptions about their validator sets. So for example, on Ethereum, there is a base assumption, a fixed topology for the validator set. That means that there's a master chain, this beacon chain, which knows about the validator sets and can assign validators to particular shards. There's this kind of logically centralized control plane for validators. But other types of chains, private or permission blockchains, or chains which are proof of stake, they might have different assumptions on their validator sets. There could also be regulatory or enterprise blockchains, which won't even be able to participate at all on public networks like ETH 2.0 and Polkadot because they need that kind of control on their validator set. So in a blockchain world that includes not only ETH, Polkadot, but also Terra, Solana, Cosmos chains, enterprises, governments, it won't be possible to have everyone on a single chain. In an ecosystem topology where there are some blockchains that have sharded validator sets and others that aren't, IBC is designed to work with all of them. And more importantly, IBC can also work in scenarios where there are no validators at all. And that's the kind of design parameters that we really started with. All of this is supported by a relayer architecture. And so what you see in this diagram here is what happens when a token transfer, for example, is conducted over IBC. So what I stated before in the shipping container metaphor, you have these data packets which are packed in containers which are defined by IBC. IBC defines the container size, but you still need someone to ferry those containers over to the other side. And again, this is a very important part about the security design of IBC. So through the system of handshakes, which is very similar to, it has been modeled off of the TCP/IP protocol, IBC establishes secure connections and channels and ports. And then the relayer architecture under that takes these nicely packaged pieces of data, transports them over to the other chain, and the other chain is able to handle whatever logic is packed in those containers. So for example, in this case, you can see what happens in a token transfer. On chain A, there is a certain proof that these tokens do exist. They're in for Cosmos SDKs in the bank module, for other chains in other types of modules and or contracts. The token proof is relayed over by the relayer. And this kind of receipt is received by the IBC client on chain B. And now chain B knows, okay, these tokens do actually exist on chain A, and chain B can then, and chain A can then escrow these tokens, and chain B can then mint the corresponding tokens on that chain. And all of this transfer of packet is handled by relayer architecture. And so what we've done is really decoupled the validation aspect from the transport aspect. So now you don't have to rely on these bridges, which have their validator sets, which are relying on kind of guardians to make sure or catch the faulty transactions or invalid transactions. All of this is already verified on each chain side by the clients on each chain side. And so the relayer or the actual transport system doesn't have to do anything with the security of the packet. And this is what we've seen right now in the current state of IBC in the Cosmos ecosystem. So this is a screenshot that I took this morning of map of Zens, and you can see the networks which are currently connected via IBC. The two highest transaction volumes are over Osmosis and the Cosmos Hub itself, and these are primarily being driven right now by the two DEXs that are live. Probably a lot of you have heard of these DEXs, and we can see already that the volume of mostly in this case fungible token transfers over IBC has really ramped up over the last months that this has been live. So again, IBC for us is the protocol that really enables this vision of the Internet of blockchains. There are no trust assumptions. It's built for dynamic topologies, but it can also connect to Polkadot, ETH 2.0, Celo, Near, Harmony, and we're going to talk about a few of these upcoming exciting integrations later on in the presentation. It really allows us to see the full vision of a blockchain internet that includes all of the chains and also private and permission blockchain ecosystems.
I just want to jump back to this diagram and talk a bit more about what's actually happening under the hood with IBC. So when these packets get passed by, we're going back to this shipping container metaphor. You know, the only way that the receiving side can accept these shipping containers is if they're the exact size that they expect them, you know, whether it's because there's a crane waiting to pick them up or whether because there's a semi-truck who's expecting that exact size to come on. But what's really cool is that the shipping ship, that relayer, et cetera, you know, they don't really need to know what's in the contents. All they need to do is move it across. But on the side of that shipping container, you can imagine there's a label slapped there that says, you know, who it's to, who it's from, but also there's a stack of papers. And so these are a little bit like Visa papers or something like that. Those Visa papers contain information about the source, things about the validator set there. That information includes, you know, what kind of consensus is on the other side? Is it Tendermint? Is it Grandpa? Is it something like ETH 2.0? IBC allows for all the different types of validator set and consensus mechanisms over there, as long as they have what's called a light client. And so the light client means that you can include a succinct amount of information, like header files from the last time you communicated with this other side. That can be validated really easily. So it's like just flipping through a passport book and be like, ah, yes, these are legit. I'm stamping this. I'm calling this legit because I understand that there's a government on the other side that runs, you know, a security system that I believe in. You know, I understand what works over there, and it's inside of my list of recognized consensus algorithms. So therefore, I accept it as valid, and I'll let it go on to the actual destination. And on the actual destination is where you unpack the contents. And that's where you have what's called the application layer IBC protocol. So the first one that's been published is the token transfer protocol. And that's the one that expects to find inside of that shipping container some tokens with a destination address and a recipient address. But it could be a lot of different things inside of there. First one is the token transfers, and that's the fungible token. Next one coming out would be NFT. And so that sort of doesn't just say how many of what kind of token, it says what's the ID, what's the denom. Another thing you'll see coming out being worked on by Band Protocol is just arbitrary Oracle data. So again, the information inside these shipping containers could be anything. It could be price feeds. It could be any of the kind of data that all of these oracles across different networks are already doing a lot of work delivering to different destinations. Now you don't need like a very custom solution of like thresholds of different participants who are all guaranteeing that this information is correct. As long as it's packed correctly inside of an IBC packet, you can guarantee that it actually came from where it said it came from. Now you have to also understand that person who's sending it decided that this information was valuable, but that's a different trust assumption. It's the fact that it came from that place is what IBC guarantees. Another protocol coming out at the application layer is interchain accounts. This is a really exciting one, and it's kind of broad, but it enables a few different interesting things. It's essentially the same capability that you see on shared state virtual machines like the EVM or CosmWasm when you have a smart contract, which is also itself an account. So smart contracts can carry a balance, which is why smart contracts are often used as multi-sigs, sort of acts as a stand-in for a user account instead of a contract account. But in a blockchain scenario, you're not really able to do that. You're not able to have an account on one blockchain represented on a different blockchain. And that's what interchain accounts allows you to do. It means that arbitrary messages, which would normally be submitted directly to that blockchain, can be submitted over IBC on behalf of an account on that origin chain. And so one of the really cool things that enables is, for instance, the community pools. These inflation funding mechanisms that are often controlled by token holders, they're a bit like DAOs. That DAO itself, which has tokens on chain A, can now send those tokens to chain B, and it can collectively manage those tokens. So you could imagine the Cosmos Hub has a community pool with about $17 million worth of atoms. They may want to send some of those atoms over to Terra, put them in the different DeFi mechanisms that are going on over there. You know, they can collectively manage funds as an account themselves. So you have blockchains controlling accounts on different blockchains with interchain accounts. Another version of using that capability is staking derivatives. So if you've got a bunch of Cosmos atoms on the Cosmos hub, but say they were owned by something like the Terra community pool, it has inflation. Maybe the Terra community pool decided to buy a bunch of atoms. Now they're like, okay, well, what do we do with our atoms? They can move them back to the Cosmos hub and they can stake them. So they can start earning rewards collectively on the Terra chain. Now, what they can also do is make a representation that says, all right, everybody put your atoms here. We'll stake them for you on the Cosmos hub, but we'll print vouchers for you on our chain. These vouchers, can be transferred freely, bought and sold. Whereas when the actual assets are locked up and staked, usually it's 2 weeks to unbond. So liquid staking means that those assets can be earning while locked and bonded, while still being transferable as vouchers on a different blockchain that has its own rules about maybe you can only transfer 50% of them at a time because the rest of them are locked up. But it enables a really clever way to get staking derivatives through the IBC protocol. Interchain security is another really exciting application layer protocol that's becoming possible. Interchain security allows that the contents of those shipping containers is actually a representation of the validator set on a different blockchain. And so what that makes possible is being able to use the same validator set on multiple blockchains. So this is also known as replicated validation. So you could take, for instance, the entire validator set of the Cosmos hub, or maybe it's the other way around, the entire validator set of Terra, and I want to launch a new blockchain, but in order to have a safe and secure blockchain, I need to have a robust validator ecosystem, and I need to have a token that has a large market cap so that it's not susceptible to attacks by buying up enough of the token to attack the network. So I might want to borrow the security of Terra or Cosmos hub. So if I convince the validators of the Cosmos hub that my blockchain is cool, it could be profitable, they can decide that, yes, I'll validate on your blockchain. Typically, they would have to buy a bunch of my token in order to join. So that's a very overhead cost for them to decide, okay, is it worth the risk of joining this network? Is it going to cost me a bunch of money? When am I going to earn it back? But if they're using interchain security, they would be eligible to validate on your chain just because they have atoms, or the other way around, just because they have Luna. And that means that they don't have to put in a huge overhead investment to join your validator set. And you, as a new blockchain, receive the full security of this large blockchain as long as you pay some of your fees up to them the same way you would have done to your other validators. This also allows Cosmos assets in Terra with our basic ICS20 token transfer. So this is the version of the application layer protocol that's going to become enabled as soon as Terra updates with IBC. This is the first one that's live on all the different networks. That means you're going to be able to see atoms coming over in the Terra ecosystem. You're going to be able to see Crow from crypto.com or Akash or Osmo or Iris or all the other sort of Cosmos-specific coin types that are now circulating across the internet of blockchains. And these assets can now be used in the different DeFi protocols that are happening inside of Terra, locked up for collateral, used for loans, all sorts of things like that. You could also imagine, like the scenario I said earlier, with interchain accounts, that the Cosmos hub might control an account on Terra. They might decide, you know what, Terra is such an important part of our ecosystem that as a network, as a blockchain ourselves, we're going to invest in Terra. So the community pool of Cosmos might decide to buy a bunch of Luna tokens and keep that in their treasury. Maybe they want to participate in DeFi. Have this capability of DAOs, which are really economic entities themselves, collectives who are managing these funds, which are coming from inflation from the blockchains themselves. It's really like blockchains as organizations, and it allows some really cool business to business or blockchain to blockchain sort of DAO to DAO type operations. You're also going to see Terra assets on the Cosmos DeFi products. So this is really exciting. Right now we have a lot of really cool DEXs and AMMs like Osmosis and the Gravity DEX and the Cosmos Hub. But the Internet of Blockchains doesn't have a really strong stable token story right now. We've yet to be connected really well to Ethereum, where most of the stable tokens exist. So we're really excited to see USDT come into our space and really give the capabilities that are missing right now across the AMMs for really advanced traders who need stable tokens to move into different positions, to long and short in different times when they're expecting the price to go in different ways. So we'll be able to see all sorts of Terra assets moving over there. We'll also have access to the crypto.com NFT marketplace. So NFTs are booming across the ecosystem. In the Cosmos space, probably crypto.com is the one that's most active. With the NFT protocol level of IBC, they'll be transferable over IBC as well. So you'll have access to different marketplaces, liquidity there. Secret Swap is an AMM on the Secret network. So they use the secure enclaves to execute state updates privately. So they have an AMM there, which is completely private. If you need to go over and protect your privacy while doing trades, you can move assets over IBC into the Secret network and partake in their applications. You could also imagine paying for compute on a cache. So Akash is a decentralized cloud platform. If you've got a DAO out there right now and the DAO wants to have a website, you have to elect somebody to be the actual private individual that owns that website domain, has a credit card in there, pays the monthly subscription fees. It really breaks down the trustless assumption of these decentralized organizations. However, with products like Akash, you're able to have an entire crypto native payment flow. You're able to have a DAO who actually owns the computer cloud instance that's running the website or running the different infrastructure that you use inside your business. Decentralizes a lot of the otherwise privatized and private entity-enabled infrastructure that we see in Web 2.0 world. You can also imagine using the distributed VPN from Sentinel. So this is a VPN for private internet access that, again, doesn't require you to have a credit card or an account in a private system. It's fully decentralized, so you use crypto native aspects of all of it. You can also imagine having ICS-20 on CosmWasm itself. So right now, the IBC transfer module is native to the Cosmos SDK. It's written in Go, and it's part of a typical Cosmos SDK app package. However, of course, one of the more exciting ways to build in the Cosmos ecosystem is by deploying smart contracts into CosmWasm instances, like the one that's run on Terra. ICS-20 has been written in CosmWasm Rust so that it can be run as part of a smart contract. This was built by Confio, the same team who actually built CosmWasm itself. And that means that inside the smart contract language, you have all of the abstractions you need to send a token from a smart contract, send a CW20 smart contract token over IBC, and have it land on the Cosmos hub, be able to go into the DEX there or any of the other connected IBC applications that are across the interchain. This is currently supported by the TypeScript relayer. We have 3 relayers in our ecosystem, one written in TypeScript, one written in Golang, and one written in Rust. TypeScript is the one that's maintained by the CosmWasm team, Confio, and so they've done a special focus on making sure that CosmWasm features are well supported. Golang is also integrating it right now, although to use it today, you'd want to use the TypeScript relayer. Cosmos and beyond. So once these networks are connected, you can imagine that it doesn't stop. Beyond IBC, there's a lot of other bridges inside the Cosmos space to the networks which are either currently unable to support IBC because they don't have fast finality and efficient light clients, like Celo, which is an EVM space but has a light client that uses ZK proofs. They are working on a light client for it to make it possible with IBC, but there's other bridges that become possible there. Beyond that, you have access to things like Iris. Iris is an IBC-enabled Cosmos SDK chain in China. The team building at Bianji has strong connections to the Chinese government. They're really working hard to make regulated and enterprise-ready blockchains because China's very skittish around cryptocurrencies, but they understand the power of blockchains and how important it is for enterprise to grow. So they have open permission blockchains that make sure that they're regulatory compliant and enterprise enabled. One of the really cool things happening right now is that the Chinese government is having a sort of like national library of cultures. So they're putting all of these ancient artworks on there to represent Chinese history, but they're inside one of these open permission blockchains. But with IBC, since it doesn't care about what kind of blockchain you're on either side, you can transfer one of these NFTs from this permissioned blockchain onto Iris, which is a public blockchain. From there, you can go on to Cosmos, you can go on to Terra, anywhere that else is IBC enabled. We're also looking forward to seeing Substrate support IBC with a palette. It's being built by Octopus Network. One of the first networks to have this run will be a Bitcoin bridge built by Interlay. So you can imagine Substrate is a very powerful framework for building blockchains. It's one that's mostly used to connect to the Polkadot network, but it's not required to. Substrate also allows you to run your own validator set. It uses GrantPaw mostly for consensus, although it also has swappable consensus. As long as that consensus has an efficient light client, it can use IBC, which means that you could imagine running a Substrate-based blockchain, uses its own validator set, has IBC, and from all other appearances is just part of the native internet of blockchains. It's not part of the intranet of Polkadot, but it has access to everybody else the same way that Cosmos SDK chains already do. I'm gonna grab my charger and let Charlie tell you bits about some of the resources from the things we just talked about.
So yeah, as we showed before, there was a screenshot from Map of Zens, and I can actually see in the questions that Bieselrich is asking for a link to Map of Zones. So here in the list of resources, you can see Map of Zones. This link of this list of resources will obviously be available as well in the information section on the actual YouTube video. Some of the resources that we find to be the most useful if you're starting out looking at how you can work with IBC are the ones listed, obviously the docs of the Cosmos network, as well as the repo itself. IBC Go has a very extensive documentation inside the docs directory. TypeScript Relayer has also a really nice tutorial which shows you how to spin up chains and use the relayer. The same goes for the Golang relayer and the IBCRS. So this is the Hermes relayer, the Rust relayer that we talked about before. All three of these relayer repos have tutorials which really allow you to play with interacting with IBC and relaying those transactions back and forth. All the relayers also have pretty nice queries. You can see the number of packets in a queue. You can see what is the status of your transaction, etc. As well, we put the link to the docs on CosmWasm, which tell you how to use the CW20 ICS20. Map of zones is, like I said before, this visualizer, IBC visualizer. You can see some more specific information about each zone and kind of the transactions going between each zone. And MintScan and IBScan are two of our bigger explorers that you can actually see the IBC transfers coming in and out.
Got to jump in a little bit to code. So this is some screenshots from the CW20 ICS20 repo that's linked in the last slide. Just sort of shows you what the transfer message looks like. So this uses the standard CW20 receive message from a CW20 contract. Data sent along with that message must be JSON serialized transfer message that includes the channel, the remote address, and the timeout. So these are different aspects of an IBC packet that I'll show you in just a second. Channels and ports basically direct the packets to very specific pieces of code. The channel is basically information about who am I talking to, so what blockchain is on the other side. And then the port is which part of this blockchain state machine should this information be directed to. So in this scenario, you'd be directed to the ICS20 transfer module on a standard Cosmos SDK chain, who's expecting an IBC packet that looks like this. So that tells you what's the source port and the source channel, because on both sides there's a port and there's a channel. It tells you what the token is, tells you who the sender is, who the receiver is, and has information about timeouts, because you can imagine if you send a packet out into space and you're wondering, I wonder if the other side got it. I'm still waiting to get confirmation that they received it, because these handshake protocols, they need to acknowledge that you actually received it, otherwise you can't rely on it. So you add a timeout height, because you want to say, okay, if you don't respond within this time, I'm going to assume that message got lost and it got lost to space and didn't happen, and I'm going to unlock those tokens that I previously locked. When it comes to the CosmWasm implementation, there's also queries. You can check out what the port is. You can list all the channels. You can get the port from asking specific channel ID. And the receiver, the counterpart to send is receive. Must be implemented by a contract that wishes to manage the CW20 tokens. This is generally not implemented by a CW contract. So like I said a minute ago, this smart contract is expecting on the other side a standard ICS20 Cosmos SDK module to receive it. Once it's over there, it's known as a native coin type, and it's able to be transferred in all the normal transfer message types that talk directly to a Cosmos SDK chain. Because, of course, Terra is both a Cosmos SDK chain that has these native transfer, all these sorts of message types, while it also contains CosmWasm, which is a virtual machine that you submit transactions directly to. Just one more time, a shot at what the IBC packet looks like. So this is the one that's specifically for transfer. But when it comes to processing this, it's already been verified by the standard IBC module. So once it makes its way through the IBC module, that's kind of like the bouncer at the door who confirms that, yes, you actually came from the blockchain you said you came from. And yes, I'm going to update my records that we still know about this blockchain. And the last time we talked to them was right now. And this is what the last header said about what the state of that blockchain is. They hand it off to the application layer, and this one again, the IBC transfer module, who actually takes that information and does something interesting with it, like mints a new token on this side because they know on the other side it got locked up. That's our presentation. Thank you. Charlie, the IBC product lead. If you want to get a hold of her, it's charlie@interchain.io. I'm Billy, Cosmos Hub lead. If you want to get a hold of me, I'm Billy@interchain.io. We went a little fast with the presentation. I think we were supposed to have an hour, but assuming that that was a lot of information, which I know it was, there might be some questions out there. So would be great if anybody out there did have ones. We'd be happy to dive in while you still got us. First question was, can I have a link to the map of zones? The answer was yes. We're going to also have these links shared widely with the Terra team. They said they'd give us a hand making sure that that got spread.
If there are no questions upcoming, you also have our contacts here on this page. So feel free to reach out. We're always open to answer any questions. We also have Cosmos Hub Discord or Cosmos Discord, which you can join. There are specific channels about IBC. A lot of people ask questions which are pertaining to implementation of IBC, and we are usually pretty prompt at answering those as well. So
yep,
feel free to take questions.
Find that at cosmos.network/ecosystem. It's one of the no, cosmos.network/community. Anyways, go to cosmos.network and click around. See if you can find it. Cool. Then yeah, we'll wrap up here. Thanks very much for y'all's time. I hope that gave you enough to start thinking on and inspired you to dig a little deeper and get excited about IBC.
Thanks, everyone.